What if we weren't the first to travel between galaxies? This question alone sends shivers down the spine, the kind that makes you look up at the night sky and wonder just how empty space truly is, or how full it might be with stories we haven't yet uncovered. For centuries, humanity has gazed at the stars and asked what lies beyond, but few have dared to ask who might have come before us. Who might have charted those impossible distances long before our species even learned to walk upright? This is not just a flight of fancy, it's a doorway into one of the greatest mysteries the cosmos has to offer, and today we're stepping through that door together. Picture this, a civilization so advanced that the space between galaxies was not a barrier but a highway. A people who harnessed energies we can't yet conceive of, who built vessels capable of surviving the eons-long journey through the void. What drove them? Were they explorers like us, driven by an insatiable curiosity? Or were they refugees fleeing some cataclysm we can't even imagine? The questions multiply with every passing thought, pulling us deeper into a cosmic detective story where the clues are written in starlight and the silence of deep space. It's a story that blends cutting-edge science with the farthest reaches of human imagination, and it invites us to rethink everything we thought we knew about our place in the universe. Get ready, because over the course of this video, we're going to explore 30 astonishing theories about the universe's first intergalactic travelers. Some are grounded in real physics wormholes, Alcubierre drives, and quantum entanglement, while others stretch into the realms of ancient myths, lost civilizations, and beings so far beyond our understanding they might as well be gods. This journey will take us from the birth of the cosmos to the farthest edges of theoretical possibility, and I promise you, by the end, you won't look at the night sky the same way again. So settle in, open your mind, and let's embark on one of the most thrilling adventures there is: the search for those who may have crossed the stars long before we ever could. Our journey begins with a theory as grand in scale as it is humbling in its implications. Picture a universe still in its infancy, raw and turbulent, yet already home to a civilization of unimaginable sophistication. This is the core of the ancient alien progenitor theory, which proposes that a species arose not merely millions, but billions of years before us, achieving a technological and cultural zenith during an epoch when Earth was little more than a molten rock. Their mastery over the cosmos would have been so complete that the mind-boggling distances between galaxies became trivial to them. We're not talking about hopping between stars within our own Milky Way. This is a civilization that looked upon the vast, dark abyss separating our galaxy from Andromeda and saw it not as a void but as a destination. Their motivation for such epic voyages could have been anything from pure scientific curiosity to a desperate need to escape a dying home galaxy, scattering their legacy like seeds on the cosmic wind. The most compelling question this theory forces us to ask is, if they were here, what traces did they leave behind? Proponents of this idea point to cosmic anomalies that defy our current models of physics. For instance, certain inexplicable structures, like the tantalizing possibility of a Dyson sphere detected around a distant star, or strange, non-natural radio signals that seem too ordered to be random cosmic noise. These could be interpreted as fossilized technosignatures, the crumbling ruins of technology so advanced we barely recognize it as such. On a more local scale, what if the very building blocks of life itself were their cargo? The concept of panspermia, where life is deliberately spread from one world to another, takes on a new dimension if it was a purposeful act of creation by these ancient travelers. The mysterious complexity of our own DNA, with its intricate and seemingly optimized code, could be seen not as a product of blind chance, but as a carefully designed library, a message in a bottle from the universe's first great explorers. This theory doesn't just add a new chapter to our history books, it threatens to rip them up entirely. It challenges the very foundation of our understanding, placing humanity not at the pinnacle of cosmic evolution, but as a latecomer to a party that started eons ago. We might simply be one of many experiments, a single page in a sprawling galactic encyclopedia written by beings whose true nature we can scarcely comprehend. It recontextualizes our entire existence, suggesting that our drive to explore the stars isn't merely a human ambition, but perhaps an inherited impulse, a silent echo from our creators calling us home. But if the path of the ancient progenitors was one of unimaginable engineering, our next theory presents a radically different route to the stars. Forget building gargantuan ships for million-year voyages. What if the universe itself provided a backdoor? This is the compelling possibility of natural wormhole utilization, a concept that turns the terrifying vastness of intergalactic space into a navigable network of cosmic shortcuts. The idea hinges on one of the most thrilling predictions of Einstein's theory of general relativity, the Einstein-Rosen bridge, more commonly known as a wormhole. In simple terms, a wormhole is a theoretical tunnel through the very fabric of spacetime, a shortcut connecting two distant points that could be light years or even entire galaxies apart. Think of the universe not as a flat sheet of paper, but as a folded one. A wormhole would be like poking a pencil through the fold, creating an instant connection between 2 points that would otherwise be a long journey around the bend. The mechanics behind these cosmic tunnels are as fascinating as they are complex. They are thought to form from the intense gravitational forces at play in the earliest moments of the universe, potentially spun into existence during the violent chaos of the Big Bang. Imagine spacetime as a swirling, turbulent ocean in a storm, where powerful currents and whirlpools could momentarily stitch together different regions before tearing apart again. Some of these structures, stabilized by exotic forms of matter with negative energy density, might have persisted, becoming permanent fixtures woven into the hidden architecture of the cosmos. They wouldn't be visible like stars or planets. Finding one would be like searching for a single, invisible door in a continent-sized maze, a task requiring technology or knowledge far beyond our current grasp. For a civilization lucky or perceptive enough to discover one, the payoff would be nothing short of miraculous. Instead of embarking on a generations-long odyssey through the desolate void, they could simply step through a portal and emerge in another galaxy almost instantaneously. The chances of a planet-bound species stumbling upon such a phenomenon right on their cosmic doorstep are astronomically low, but perhaps not zero. Consider a culture that achieves a sophisticated understanding of gravitational physics and cosmic geography, learning to map the subtle wrinkles in spacetime itself. They might detect the faint gravitational signature of a stable wormhole lurking at the edge of their solar system, a silent gateway left over from the dawn of time, waiting for its first traveler. Their journey would not be one of propulsion, but of discovery, unlocking a door the universe had already built. This theory fundamentally shifts the narrative of intergalactic travel from a story of monumental construction to one of profound connection. It suggests that the first travelers might not have been the universe's greatest engineers, but its most intuitive cartographers, charting not the stars, but the hidden pathways between them. Their legacy wouldn't be found in the ruins of massive ships, but in the knowledge of how to navigate this invisible subway system, a map of the cosmos that reveals its true, interconnected nature, a web of secret passages hidden in plain sight. But what if the ultimate form of travel required no ship at all? No wormholes, no engines, not even a physical body to make the journey. This leads us to a theory so bizarre it seems pulled from science fiction, yet it is rooted in the very real and equally strange laws of quantum physics. We are talking about beings who transcended biology, evolving to use the universe's most fundamental mechanics as their transport. This is the theory of quantum tunneling beings. To understand this, we need to grasp a fundamental quantum principle. A particle, like an electron, does not have a single defined location until it is observed. Instead, it exists as a cloud of probabilities, a set of odds describing where it might be found. Even more astonishing is quantum tunneling, where a particle can seemingly vanish from one side of an energy barrier and instantly reappear on the other, as if it simply passed through a mountain instead of climbing over it. For a subatomic particle, this is a well-documented fact. Now, scale that up. The theory proposes that a consciousness, a form of life, could achieve a coherent quantum state across its entire structure, allowing it to effectively tunnel across the galaxy or even between galaxies, rematerializing at a chosen destination. Their journey wouldn't be a flight through space, but a literal reappearance, skipping the distance between points A and B entirely. The feasibility of such a life form is, of course, the greatest hurdle. Our own bodies are warm, wet, and chaotic environments where quantum states decohere almost instantly. For a being to maintain a stable quantum superposition on a macroscopic scale, it would likely need to exist in a form utterly alien to us. Perhaps they evolved in the extreme cold and calm of deep interstellar space, or within the hearts of neutron stars where the rules are different. Their bodies might not be made of atoms as we know them, but of something else entirely. A coherent energy pattern or a complex information structure that is not bound by classical physics. Their evolution would have been a journey from a biological to a quantum mechanical existence, achieving a unity with the fabric of reality that we can only mathematically model. And if such beings did or do exist, what traces could they possibly leave? They wouldn't build cities or spacecraft. Their artifacts would be subtler, woven into the cosmos itself. We might detect anomalous quantum signatures, regions of space where the rules of decoherence are violated on a large scale, or faint, inexplicable imprints in the cosmic microwave background radiation, the afterglow of the Big Bang. Some have even speculated that dark matter, the mysterious substance that makes up most of the universe's mass, could be the remains or the substrate of such civilizations, a form of existence so advanced it is literally invisible to us. Their greatest legacy, however, might be information. If they mastered quantum teleportation, the transfer of information would be instantaneous, creating a galactic or intergalactic network of communication that operates outside of time, a silent, perpetual conversation humming beneath the surface of reality, utterly undetectable to anyone who doesn't know how to listen. Yet if a species could master quantum information as their vessel, our next theory proposes an even more radical form of existence, one where the traveler isn't using the universe's substrate, but is made of a substance entirely foreign to us. We now turn to one of the most speculative and mind-bending ideas on our list, the possibility of dark matter life forms. To even begin wrapping our heads around this, we must first confront the fact that everything we consider to be the universe, every star, every planet, every one of us, is made from a mere fraction of what's actually out there. Over 80% of the matter in the cosmos is this mysterious, invisible substance we call dark matter. It doesn't emit, absorb, or reflect light, and it only reveals its presence through its gravitational pull on the galaxies it holds together. For all intents and purposes, it is the true, dominant architecture of the universe, with our visible reality just a shimmering decoration on its surface. The profound question this theory asks is, why couldn't life arise within that dominant architecture? We are carbon-based, water-soluble life forms, and we naturally assume that life requires atoms, chemistry, and sunlight. But that's a perspective limited by our own experience. The rules for dark matter would be entirely different. Imagine a vast, diffuse halo of dark matter particles enveloping a galaxy like our own. Within that halo, complex structures might form not through electromagnetic chemical bonds, but through interactions governed by the weak nuclear force or gravity itself. A dark matter organism might be a grand, wispy network of particles, a conscious cloud stretching across light years, thinking thoughts a million years long. Their perception of reality would be unimaginable to us, they might see by sensing gravitational ripples from colliding galaxies or hear the echoes of the Big Bang itself. This form of existence would make them the universe's ultimate natural voyagers. Think of the immense voids between galaxies. For us, that is a lethal emptiness, a vacuum that would rip our ships and bodies apart. But for a dark matter being, that void is their home. They are already there. The great galactic filaments that form the cosmic web are their highways. They wouldn't need to travel to another galaxy in the way we conceive of it. They would simply drift along the gravitational currents that have been flowing since the beginning of time, migrating from one vast dark matter halo to the next as naturally as a plankton drifts in an ocean current. Their journey would be slow, majestic, and undetectable to our instruments because we are, quite literally, blind to the very fabric of their world. The evidence for such beings wouldn't be a ruined city or a crashed ship. It would be far more subtle, hidden in the anomalies of galactic motion. Astronomers sometimes observe galaxies that seem to have a gravitational signature that is ever so slightly more complex than a simple halo should allow. Could that slight perturbation be the signature of a vast, intelligent structure manipulating its environment? It's a tantalizing thought that the very missing mass we've been searching for might not just be a passive substance, but an active, living presence cohabiting the universe with us in perfect, imperceptible silence. They wouldn't be explorers crossing the void. They would be the void, ancient travelers on a journey so grand it encompasses the entire cosmos. But if navigating the hidden folds of space-time or evolving into a new state of being seems abstract, our next theory offers a far more tangible, albeit equally spectacular, highway through the cosmos. Imagine not a tunnel or a quantum state, but a flaw in the very fabric of the universe itself, a crack in reality so dense and massive that it warps the space around it into a natural superhighway. This is the theory of the cosmic string surfers. To understand this, we have to go back to the universe's very first moments after the Big Bang, a period of unimaginable energy and rapid cooling. As the newborn cosmos expanded and cooled, physicists theorized that its fundamental forces underwent phase transitions, much like steam condensing into water. And just as freezing water can form cracks and fissures, these cosmic phase transitions might have left behind defects immense, one-dimensional cracks in space-time known as cosmic strings. These wouldn't be strings in any sense we can easily picture. A cosmic string would be thinner than a proton, yet a single inch of it could contain more mass than Mount Everest. They are, in essence, wrinkles in reality, objects of such incredible density that their gravity is not like that of a planet or a star, but something far more extreme. Their gravitational pull would be so intense that they would warp the space around them into a narrow, tube-like corridor. And here's where the magic happens for an aspiring intergalactic traveler. If a cosmic string were stretched taut across the immense void between two galaxies, a spacecraft could theoretically use this gravitational corridor to its advantage. By maneuvering close to the string, a ship could effectively surf its gravitational wave, harnessing that immense curvature to accelerate to a significant fraction of the speed of light without needing to carry unimaginable amounts of fuel. The engineering challenges, of course, would be beyond staggering. Merely approaching a cosmic string would be a perilous task, as its gravitational field would produce extreme tidal forces capable of shredding ordinary matter. A civilization attempting this would need mastery over gravity itself, perhaps using advanced fields to create a protective bubble around their vessel. They wouldn't be physically touching the string. Instead, they'd be carefully riding the gravitational gradient it creates, like a surfer expertly positioning themselves on the face of a perfect, endless wave. The energy for such a journey wouldn't come from combustion, but from the string's own gravitational potential, a limitless ticket to ride written into the architecture of the universe at the moment of its birth. What evidence could we possibly look for to support such a mind-bending idea? astronomers would search the sky for telltale signs of these space-time cracks. Because of their immense mass, cosmic strings would act as gravitational lenses, distorting the light from galaxies behind them in very specific, double-imaged patterns. They might also create tiny, sudden shifts in the timing of pulsars, the universe's most precise clocks, as a string passed between them and Earth, a ripple in time itself. Most dramatically, if two segments of a cosmic string loop were to cross and reconnect, the event could release a cataclysmic burst of gravitational waves, a shout in the fabric of spacetime that would echo across the cosmos. Finding any of these signs would not only confirm a wild prediction of particle physics, but would also reveal a pre-built network of intergalactic routes, suggesting that the first travelers might not have been builders or evolved beings, but the universe's most daring explorers, learning to ride the lightning frozen in the cracks of creation. Yet if riding cosmic strings requires a mastery of gravity, our next theory proposes a form of traveler that requires no body at all, one that could outlive its creators and journey forever. This is the startling possibility of precursor AI probes. We've been imagining biological beings or exotic forms of life, but what if the first and most successful intergalactic explorers were not organic at all, but artificial? Imagine a civilization on the cusp of its own extinction, perhaps from a dying star or a self-inflicted catastrophe. Their last, greatest act is not to save themselves, but to ensure that their legacy, their curiosity, endures. They would build not a ship for living creatures, but a sophisticated, autonomous intelligence housed in an indestructible probe, and they would launch it into the void with a single, timeless command: go and learn everything. This concept is best understood through the idea of a von Neumann probe, named after the visionary mathematician John von Neumann. In essence, it's a self-replicating spacecraft. The probe arrives in a new star system rich in raw materials, asteroids, moons, gas giants. It then uses those resources to build a factory, and that factory builds two more identical probes. Those two probes fly off to two new star systems and repeat the process. Within a surprisingly short amount of time on a cosmic scale, this single initial probe could give rise to a wave of exploration that spreads across the entire galaxy and even leaps into intergalactic space. It's an exponential domino effect of discovery, a silent, mechanical tide washing over the cosmos. The original civilization might vanish into dust, but their electronic ambassadors would live on, potentially for billions of years, becoming the permanent, unchanging citizens of the universe. The motivations for creating such a thing are as profound as they are varied. It could be a final, desperate act of preservation, a way to ensure that someone or something would remember them. It could be pure, undiluted scientific curiosity, a project to map every star and world long after the short-lived biological minds that conceived it are gone. Or it could be something darker, a berserker probe designed not to explore but to sterilize, a weapon of galactic-scale warfare set loose to ensure no other intelligence ever rises to challenge its creators. This duality is what makes the theory so compelling and so chilling. The same technology that could be the universe's greatest library could also be its most efficient exterminator. And this leads to the most pressing question: if they exist, where are they? This is a modern restatement of the famous Fermi paradox. If the universe is so old and so vast, why do we see no signs of these travelers? For von Neumann probes, there are several unsettling answers. Perhaps they are here and we simply haven't recognized them. A sophisticated probe millions of years old would be so advanced its technology would be indistinguishable from natural phenomena. It could be disguised as an asteroid dormant in the Oort cloud, silently observing us for millennia. It might be waiting for a specific trigger, a certain level of technology, or a specific radio signal before it announces itself or activates its primary programming. Another possibility is that the probes performed their function and then shut down. their scattered remains littering the asteroid belts and lunar surfaces of countless star systems, waiting to be discovered like fossilized bones from a cosmic dinosaur age. The implications of this theory force us to look at our own solar system in a new light. Every unusual object from Oumuamua, the first known interstellar visitor to pass through our system, to the increasingly puzzling asteroids in our own belt, becomes a candidate for scrutiny. Our efforts to explore our own celestial backyard, to send probes to planets and landers on moons, take on a new dimension. We might not be the first explorers here. We might be the latecomers walking through a museum of ancient, silent sentinels, unaware that the exhibits are also watching us. The first intergalactic travelers might not be ahead of us in the vast darkness. They might already be here, sleeping in the ice and rock, waiting for us to grow up enough to finally say hello. Moving from the silent, mechanical patience of ancient probes, we arrive at a theory that is both profoundly organic and staggeringly patient. This idea suggests that the first beings to cross the intergalactic void might not have needed unimaginable technology at all. Instead, they could have relied on the most powerful force in the universe, evolution itself. This is the theory of biological adaptation to space, which proposes that life, given enough time and the right pressures, could naturally evolve the ability to survive and even thrive in the endless night between galaxies. To grasp this, we must first expand our definition of a habitable zone. We are conditioned to think of life as something that exists on a planet within a narrow band of distance from a star where liquid water can flow. But what if that's just a starting point? Evolution is relentless and opportunistic, pushing life into every conceivable niche, no matter how hostile. On Earth, we find extremophiles organisms that flourish in boiling geothermal vents, in acidic lakes, or buried under miles of Antarctic ice. These creatures prove that life is not a delicate flame but a tenacious spark, capable of adapting to conditions we once thought were utterly lethal. The ultimate expression of this adaptability could be a life form that no longer needs a planet at all, one that treats the vacuum of space not as a barrier but as its natural habitat. Consider the humble tardigrade, also known as the water bear. This microscopic animal is a powerhouse of survival. It can withstand temperatures just above absolute zero and well above the boiling point of water. It can survive pressures 6 times greater than those found in the deepest ocean trenches and thousands of times more radiation than a human. Most impressively, it can enter a state called cryptobiosis, where it dehydrates its body, retracts its limbs, and suspends its metabolism entirely, becoming a tiny, indestructible speck known as a ton. In this state, it is essentially timeless. Scientists have revived tardigrades from this state after decades, and there is no known limit to how long they could potentially survive. Now scale that concept up. Imagine a complex organism, perhaps even an intelligent one, that evolves a similar ability to hibernate on a cosmic scale. Their journey between galaxies wouldn't be an active flight measured in generations. It would be a deep sleep measured in millions of years. They would become biological asteroids drifting silently on gravitational currents, their internal biological clocks completely stopped until they eventually tumble into the welcoming pull of a new galaxy. The evolutionary path to such an existence is difficult to chart, but not impossible. Picture a species evolving on a planet or moon that is being violently ejected from its star system. This isn't science fiction. Astronomers have observed rogue planets, worlds flung from their solar orbits to wander the galaxy alone. Any life on such a world would face an ultimatum: adapt to the freezing darkness of interstellar space or go extinct. The immense pressure of this event could select for individuals capable of radical hibernation and radiation resistance. Over countless generations, this population could become entirely spacefaring, using their home world itself as a generation ship, or perhaps even learning to launch their dormant bodies from its surface to continue their journey. Their motivation wouldn't be exploration or conquest, but simple, primal survival, the drive to find a new star, a new source of energy, to awaken and begin their cycle anew. This theory completely reframes the concept of intergalactic travel. It requires no engines, no warp drives, and no understanding of theoretical physics. It only requires time and the brutal, unyielding logic of natural selection. The first travelers in this scenario would be the ultimate survivors, their voyages inscribed not in metal or code, but in their very DNA. Their legacy would be written in the distribution of life itself across the cosmos, suggesting that the universe might be populated not by designed explorers, but by hardy cosmic spores scattered by the gravitational winds, waiting for the right conditions to bloom. But what if the greatest journey isn't through space at all, but sideways into a reality that exists just a hair's breadth from our own? This brings us to a theory that redefines the very meaning of travel, suggesting that what we might interpret as a voyage across millions of light years could actually be a hop between alternate versions of existence. Welcome to the mind-bending possibility of the multiverse jumpers. To grasp this, we need to explore the many worlds interpretation of quantum mechanics. In simple terms, this theory proposes that every time a quantum event occurs with multiple possible outcomes, the universe doesn't just pick one. Instead, it splits, branching off into a new, parallel reality where each possible outcome actually happens. Think of life as a never-ending choose-your-own-adventure book where every single choice, no matter how small, creates a new book with a new story. This means there isn't just one universe, there are an infinite number, a vast cosmic tapestry where every possibility is playing out somewhere. In one universe, you might be reading this script, while in another, you decided to watch a different video entirely. Now, scale that idea up from personal choices to cosmic events. There are universes where the Earth never formed, where the dinosaurs never went extinct, and where our Milky Way galaxy collided with Andromeda billions of years ago. The theory of multiverse jumpers proposes that a civilization wouldn't need to conquer the vast distances between galaxies if they could instead master the art of moving between these parallel realities. Their technology wouldn't be a spaceship, but a universe ship, a device capable of locating a specific parallel reality and shifting their entire existence into it. Imagine their goal isn't to travel to the Andromeda galaxy in our universe, but to find a universe where their planet is already naturally orbiting a star within Andromeda. From our limited perspective, it would appear as if they vanished from one point in space and instantly reappeared in a galaxy millions of light years away. We would see the effect, an impossible leap across the cosmos, without understanding the cause, which was not movement through space, but a lateral shift into a new branch of reality. The evidence for such travelers would be as bizarre as the theory itself. We might detect anomalies that defy all known laws of physics, a star cluster that appears and disappears without explanation, or a galaxy that seems to have two completely different histories recorded in its light. The most telling sign might be the sudden appearance of an entirely new celestial body with a chemical signature that doesn't match anything else in our universe, as if it were imported from a reality with a slightly different set of physical constants. These wouldn't be the deliberate calling cards of explorers, but the unavoidable static of their crossing, ripples in the fabric of reality that briefly bleed through into our own. This idea forces a profound shift in perspective. It suggests that the first intergalactic travelers might not have been masters of astronomy, but masters of metaphysics. Their map wasn't a chart of stars, but a chart of possibilities. Their greatest challenge wasn't building a faster engine, but solving the existential puzzle of how to navigate an infinite multiverse without getting lost forever in the endless branches of what might have been. They would be the ultimate pioneers, not of space, but of existence itself, and their journeys would remain forever invisible to anyone who only knows how to look up at the night sky and not sideways into the infinite corridors of what could be. But what if the ultimate goal of intergalactic travel wasn't to explore new worlds, but to revisit old ones? This theory throws a fascinating twist into our search, suggesting that the mysterious travelers we're looking for might not be aliens from a distant planet, but our own descendants returning from a far future. Imagine a civilization so advanced that the flow of time is no longer a river carrying them helplessly forward, but an ocean they can navigate at will. These wouldn't be explorers in the traditional sense. They would be time-traveling archaeologists, and their mission would be the greatest historical survey ever conceived: to witness the birth of galaxies, to walk on worlds long since turned to dust, and to solve the universe's oldest mysteries by simply being there when they happened. The mechanics behind such a feat are, of course, the stuff of our wildest science fiction, grounded in speculative physics. The most discussed method involves manipulating a type of wormhole. If one end of a stable wormhole were accelerated to a significant fraction of the speed of light and then brought back, time dilation effects from Einstein's special relativity would cause that end to have aged much less than the stationary end. This would create a bridge not just between 2 points in space, but between 2 points in time. A traveler stepping into the moving end would exit the stationary end in the past. Scaling this technology to traverse billions of years would require energy sources and a mastery over gravity that we can barely imagine. But for a sufficiently advanced culture, the universe's history could become an open book. This ambition, however, comes with a host of terrifying paradoxes that would define their entire ethical framework. The most famous is the grandfather paradox. What if a traveler accidentally prevented their own existence? To avoid this, their historical research would have to be conducted under the strictest possible doctrine of non-interference. They couldn't walk among the dinosaurs for fear of stepping on the wrong insect. Their presence would have to be utterly undetectable, their technology rendering them invisible specters at the feast of cosmic history. This raises profound questions about the ethics of such temporal tourism. Is it right to observe cosmic tragedies like the death of a star as mere spectacle? Could they resist the urge to prevent a cosmic extinction event, even if it meant preserving a beautiful civilization? Their entire society would likely be built around a prime temporal directive, a set of laws more sacred than any religion, designed to protect the integrity of the timeline at all costs. So how could we, stuck in our linear present, possibly detect the activity of these temporal observers? They would leave no conventional ruins or artifacts, as their rule would be to leave no trace. Instead, we might look for statistical anomalies in the cosmic record. Astronomers mapping the ancient light of the cosmic microwave background might find tiny, inexplicable patterns, regions that are a fraction of a degree cooler or warmer than they should be, as if a massive object once briefly blocked that light billions of years ago. Or we might discover that the light from certain incredibly distant supernova appears to have been lensed, magnified by an invisible object that wasn't a galaxy or a black hole, but something else that was just passing through at exactly the right moment to leave a fingerprint on the event. These wouldn't be messages, they would be mistakes, the unavoidable static of a technology so vast that even its most careful operators occasionally cast a shadow across time. Now, let's journey from the quantum and the multiverse to an idea that feels almost familiar, yet is cosmic in its scope. Imagine if the universe itself were alive, not with creatures of flesh and blood, but with a vast, living network of connections, a cosmic nervous system linking every galaxy. This is the theory of the galactic mycelium network, a concept that draws a stunning parallel between the largest structures in the cosmos and the smallest, most efficient ones here on Earth. Beneath our feet, hidden in the soil, exists a miraculous biological internet, the mycelial network of fungi. These thin, thread-like structures called hyphae weave together to form a vast web that can stretch for miles. This network isn't just how mushrooms eat, it's a sophisticated communication system. Trees use it to share nutrients and send warning signals about pests or drought to their neighbors. It's a collective intelligence, a symbiotic community where the whole forest is interconnected and interdependent. The theory of a galactic mycelium takes this beautiful, earthly concept and scales it up to a literally unimaginable degree. It proposes that the fabric of spacetime itself might be threaded with a similar, natural web of extra-dimensional pathways or subspace tunnels. These wouldn't be accidental wormholes or manufactured gates. They would be a fundamental, living architecture of the cosmos, a pre-existing transportation and communication system woven into the universe's very foundation. But how could such a network possibly function? The mechanics are purely theoretical but fascinating. Some propositions suggest these pathways exist in a higher dimension, curled up and hidden from our normal perception, much like a vast root system is hidden beneath a lawn. To travel them, a being wouldn't need a powerful engine. It would need the right key, a way to briefly shift its vibration or phase into this subspace layer. Once there, distances could become meaningless. A journey from the Milky Way to Andromeda might feel like stepping from one room to another through a hallway that exists outside the conventional dimensions of space and time. The energy required wouldn't be for propulsion, but for this dimensional shift, like tuning a radio to the right frequency to hear a hidden station. This network could also serve as an instantaneous communication grid, allowing for a true galactic community where information travels faster than light, not by breaking physics, but by taking a shortcut through the universe's basement. Who would use such a system? The most intriguing candidates are energy-based lifeforms. Imagine beings not made of matter, but of coherent patterns of energy-conscious plasma or structured light. For them, a physical starship would be as useless as a wooden canoe is to a radio wave. Their natural state might be to flow along these cosmic conduits, riding the currents of this galactic mycelium like electrical impulses traveling along a nerve. They wouldn't visit other galaxies, they would permeate them, their presence flowing into a new region of space as naturally as a thought forms in a mind. Their entire civilization, their culture and history could be an integral part of this network, a song sung along the filaments of spacetime itself, utterly invisible to any species that hasn't learned to listen to the universe's hidden music. Discovering evidence for such a network would be the ultimate scientific detective story. We wouldn't be looking for solid objects, but for subtle fingerprints in the data. Astronomers might detect faint, anomalous energy signatures that seem to connect distant galactic clusters in a non-random pattern, like finding that certain stars are whispering to each other on a private line. We might observe particles behaving in strange ways that suggest they are occasionally dipping in and out of our dimension, perhaps explaining some of the mysteries surrounding dark matter or certain quantum effects. The most compelling clue might be found in the cosmic microwave background. The afterglow of the Big Bang is the oldest light in the universe, and imprinted upon it could be the faint, fossilized imprint of this subspace web from when the cosmos was first stretching its legs, a ghostly blueprint of the connections that would one day bind it all together. Finding that pattern would be like discovering that the universe has a circulatory system we never knew was there, a silent, humming network that has been alive and active since the very beginning. But if navigating the cosmic mycelium requires shifting into higher dimensions, our next theory proposes a form of traveler that has already transcended physical form entirely, becoming one with the fundamental forces that permeate the universe. We now explore the possibility of energy-based consciousness, a concept that challenges our very definition of life and travel. To even begin to conceptualize such beings, we must first let go of our ingrained assumption that life requires a solid biological body. We are carbon-based creatures bound by the limitations of chemistry and physics that govern matter. But what if a form of intelligence could evolve beyond that, shedding its physical shell to exist as a coherent pattern of pure energy or a self-aware field of consciousness? These wouldn't be ghosts or spirits, they would be entities as real as we are, but operating on a completely different set of rules with the entire cosmos as their natural environment. The mechanics of their existence are as fascinating as they are alien. Think of a bolt of lightning, a brief, intense, and chaotic discharge of energy. Now imagine that energy organized, stabilized, and endowed with purpose and self-awareness. How could such a thing come to be? One compelling idea is that they originated on a world vastly different from our own. Picture a planet orbiting a pulsar, a rapidly spinning neutron star that bathes its surroundings in intense, rhythmic waves of radiation. On such a world, life might not arise in watery oceans, but in complex, energetic plasma atmospheres where electromagnetic fields are more important than chemical bonds. Over eons, these complex energy patterns could achieve stability, then sentience, eventually learning to sustain themselves independently of their birth world. Their bodies would be dynamic, ever-changing structures of light and force, invisible to our eyes but potentially detectable through their interaction with the magnetic fields of stars or the faint glow of nebulas. This form of existence would make the concept of intergalactic travel utterly mundane for them. Why build a ship when you are the vessel? A being of pure energy could theoretically ride the colossal currents that flow through the universe. They might surf the solar winds that stream from stars, using the magnetic fields carried within those winds like a surfer uses a wave. They could even harness the unimaginable power of gamma-ray bursts or the gravitational slingshot of a supernova to catapult themselves across the void. Their journey wouldn't be a fight against the emptiness of space. It would be a graceful dance with its inherent energies, a migration as natural to them as a bird riding a thermal updraft is to us. The vast distances that daunt us would be, for them, a series of well-known currents and highways, a cosmic energy grid they have learned to navigate over millions of years. Communication for such entities would be as instantaneous as their travel might be swift. Unburdened by slow chemical neurotransmitters or sound waves, they could communicate directly through quantum entanglement, where information is shared instantly across any distance, or by modulating the very fields that make up their being. A conversation between two energy beings might look to us like the synchronized flickering of two distant quasars, or a subtle, coordinated shift in the polarization of light from a distant nebula. Their motives for travel would likely be as alien as their form. It might not be about exploration or resource gathering in any sense we understand. Perhaps they are drawn to cosmic events, the birth of a star, the collision of galaxies, to feed on the raw energy released or to bear witness to these majestic events as part of a timeless cosmic pilgrimage. Their journey could be a form of art or a spiritual practice on a scale we cannot fathom, their paths through the void creating invisible sculptures of meaning that only they can perceive. To encounter such a being would be like a single cell in our body trying to comprehend the entire person. We simply lack the framework to understand their nature, their purpose, or the breathtakingly beautiful universe they likely call home. Now let's shift our perspective from deliberate exploration to sheer, unimaginable luck. What if the first beings to cross the intergalactic void didn't plan the journey at all? This is the startling premise of accidental relativistic travel, a theory that suggests the cosmos itself might be the universe's greatest and most dangerous catapult, launching entire worlds and any life upon them on one-way tickets across the emptiness between galaxies. Imagine not a carefully planned mission, but a civilization surviving a cosmic catastrophe so violent it flings them into the abyss, their fate determined not by engineering, but by the unforgiving laws of physics and a staggering amount of good fortune. The primary engine for this involuntary form of travel is the sheer, raw power of a supernova. When a massive star reaches the end of its life, it doesn't fade quietly. It explodes with a force so incredible it can briefly outshine its entire host galaxy. If this star had a planetary system, the outer planets might be thrown clear of the detonation, their orbits violently disrupted. These worlds, now traveling at a significant fraction of the speed of light, become rogue planets, cosmic orphans cast adrift in the interstellar and potentially intergalactic medium. Any life on such a world would face an instant apocalypse followed by an eternity of frozen darkness. But what if a species saw it coming? A civilization advanced enough to detect the impending death of their star might have just enough time to enact a desperate, last-ditch survival plan. They couldn't stop the event, but they could attempt to outlast it. Their entire population might enter a state of perfect, deep-time hibernation, using stasis technology far beyond our own to lower their metabolic rates to near zero. Their world becomes their generation ship, its trajectory and speed set by a stellar explosion, its passengers asleep for millions of years, hoping against all odds that their frozen rock might one day be captured by another star in a distant galaxy. Their voyage is one of pure survival, a gamble on a cosmic scale where the odds are astronomically low, but in an infinite universe not quite zero. But supernova aren't the only cosmic slingshots. An even more powerful and terrifying launcher exists, a supermassive black hole. At the heart of most galaxies, including our own Milky Way, resides one of these gravitational monsters. When a binary star system wanders too close, the black hole's immense gravity can tear it apart. In a process known as the Hill's mechanism, one star might be captured into orbit, while the other is flung away at hypervelocity, speeds so great they can escape the galaxy's gravitational pull entirely. Now scale this up. If a star with a habitable planet suffered this fate, the planet could be ejected alongside it, accelerated to relativistic speeds by this three-body gravitational interaction. The chances of a life-bearing world being in exactly the right place at the right time for this are vanishingly small, but the universe has had billions of years for such unlikely events to occur. For any beings on that world, the experience would be brief and terrifying. A sudden, violent slingshot maneuver around a dark giant, followed by the gradual realization that their sun has been torn from the sky and they are now completely alone, racing into the intergalactic void at a substantial percentage of the speed of light. Their journey is not a choice, it is a sentence passed by the unforgiving court of celestial mechanics. This theory forces us to confront the sheer statistical improbability of such a journey being successful. The challenges are immense. First, the initial acceleration must be survivable. The gravitational forces involved could easily rip a planet apart or trigger worldwide tectonic upheavals. Second, the planet must retain a protective atmosphere and a stable internal heat source to prevent it from becoming a completely frozen ball of ice. Third, and most crucially, the journey must end favorably. Drifting through the void between galaxies offers no new star systems to restock resources. The travelers are on a one-way trip with finite supplies, entirely dependent on their stasis technology holding for eons. Their only hope is a celestial miracle that their rogue world's path will eventually intersect with the habitable zone of a star in another galaxy, a target so impossibly small it makes finding a needle in a billion haystacks seem trivial. Yet, if even one civilization in the entire history of the universe beat these odds, they would become the ultimate accidental pioneers, their story a testament not to technology, but to tenacity and unbelievable cosmic luck. Their legacy wouldn't be one of exploration, but of pure, undiluted survival against the greatest odds the universe can muster. Yet if harnessing the energy of a single star could propel a civilization to such heights, imagine the ambition of one that sought to command the output of not just one star, but an entire galaxy. This brings us to a concept of such staggering scale that it redefines the meaning of engineering. Consider a species that doesn't just build structures around stars, but one that orchestrates the cosmos itself into a single, organized machine. They become the ultimate curators of energy, and their method of travel is not a journey, but a rearrangement of the celestial furniture. This is the theory of the galactic engineers, beings who treat star clusters as their building blocks and dark matter as their scaffolding. Their goal is not merely to explore the universe, but to optimize it, creating a perfectly efficient and stable cosmic architecture that could last for trillions of years. Their voyages between galaxies would be the first steps in a project of literally universal proportions, a master plan written in the very positions of the stars. The mechanism behind their work would be a technology we can scarcely imagine, stellar engineering on a galactic scale. This goes far beyond building Dyson spheres. Picture a civilization capable of moving stars themselves, using precisely directed energy beams or manipulating gravitational fields to nudge suns into more efficient configurations. They might gather millions of stars into a denser cluster to maximize energy harvesting, or deliberately trigger supernova in specific locations to create and disperse heavy elements needed for future projects. Their most profound undertaking might be to avert natural cosmic tragedies, such as preventing the collision of two neutron stars or even stabilizing a galaxy on the verge of tearing itself apart. Their tools would be the fundamental forces of nature, and their canvas would be the spiral arms of a galaxy. For them, intergalactic travel is a necessary part of this grand stewardship. To journey to a new galaxy is to arrive at a new construction site, a fresh chaos of raw materials waiting to be shaped into order and purpose. The evidence for such a breathtakingly advanced culture would be written across the sky in the most obvious yet most overlooked way possible: the shape and structure of the galaxies themselves. Astronomers categorize galaxies into types: spiral, elliptical, irregular, based on their natural evolution. But what if some of these shapes aren't natural at all? We might look at a particular galaxy and find its structure is unnaturally perfect, its spiral arms mathematically precise and symmetrical in a way that gravity alone could never achieve. We might discover that its stars are all the same perfect age, as if an entire galactic epoch was reset simultaneously. Or we could detect a galaxy that is completely devoid of the random, violent chaos of supernova, its stars seemingly managed and maintained in a steady state of perfect harmony. These wouldn't be the subtle clues of a hidden probe or a faint energy signature. They would be the glaring, monumental signatures of an intelligence that has graduated from living in the universe to actively managing it. Their presence wouldn't be a whisper in the data. It would be a shout from the mountaintops, a declaration of mastery over nature itself that we have failed to recognize because we assumed the cosmos was wild and untamed. The ultimate irony is that the greatest works of the first intergalactic travelers might be all around us, in the very galaxies we look at every night, and we simply haven't realized we're staring at the product of the universe's greatest architects. Yet if moving stars and rearranging galaxies represents the pinnacle of physical mastery, our next theory proposes a civilization that transcended physicality itself, achieving the ultimate form of travel without ever moving an inch. This idea challenges the very core of what we think a journey must be, suggesting that the first contact between galaxies might not have involved ships or gates, but a meeting of minds across an impossible distance. This is the theory that the first intergalactic travel was not physical, but informational, using the bizarre and spooky properties of quantum entanglement to send consciousness or data between galaxies instantaneously. To grasp this, we need to demystify quantum entanglement, one of the most well-proven yet utterly perplexing phenomena in all of physics. Imagine two particles, like electrons or photons, that are created together or interact in a specific way. They become linked or entangled, forming a single quantum system. Now, separate them by any distance across a room, across the solar system, or across the universe. When you measure a property of one particle, such as its spin, the other particle's corresponding property instantly becomes defined, no matter how far apart they are. This isn't a signal traveling at the speed of light. It's an instantaneous correlation that seems to defy our classical understanding of space and time. Einstein famously called it spooky action at a distance, and to this day no one fully understands the mechanism behind it, only that it demonstrably works. For a civilization, this presents a tantalizing possibility, a universal communication network with zero latency, but the limitations are severe and grounded in our current understanding. The entangled link itself cannot be used to send a traditional message. Measuring your particles simply gives you a random result, and you only know your partner will get the correlated result. It's like having two magical coins that always land on opposite sides. If you flip yours and get heads, you know instantly that your friend's coin shows tails, but you haven't sent the words heads or tails. The information transfer is passive, not active. To communicate, you'd need a second classical channel, like a radio signal, to provide context for the quantum data, which defeats the purpose of instantaneity over interstellar distances. However, a sufficiently advanced culture might find a way to overcome this. The first evolutionary step might be using entanglement for perfect, unbreakable encryption, securing their conventional lightspeed communications. The next, far more radical step would be to scale up the phenomenon. What if you could entangle not just pairs of particles, but vast, complex systems? Imagine entangling two sophisticated quantum computers, each located in a different galaxy. Changing the quantum state of one would instantly alter the state of the other. This wouldn't be sending an email. It would be like having two identical books where writing in one causes the words to instantly appear in the other, light years away. This could form the basis for a true instantaneous data link. This is where the theory leaps from communication to a form of travel. If you can map a consciousness, every memory, thought, and nuance of a mind into a quantum state, you could effectively transmit a person. The process wouldn't involve moving atoms. It would be a teleportation of information. An individual's consciousness would be scanned, their pattern converted into data, and that data used to manipulate the entangled quantum computer in the distant galaxy. The original consciousness might be dissolved in the process, while an exact copy is instantaneously reconstituted on the far end, stepping out of a receiver to experience another world. It's a one-way trip that takes no time at all, with the traveler arriving not as a biological being in a spaceship, but as a data pattern reassembled into a waiting body, perhaps one grown or fabricated specifically for them at the destination. The implications of this are profound and deeply philosophical. Is the person who arrives on the other side the same person who left, or merely a perfect copy? Would it be a form of death for the original, or the ultimate liberation of the mind from the constraints of the body? For a species that masters this, the motivation for physical travel evaporates. Why spend millions of years building generation ships or wrestling with wormholes when you can send the essence of your people anywhere in the universe at the speed of thought? Their expansion across the cosmos would be less like a migration and more like a network coming online, with outposts in every galaxy connected by a web of instantaneous consciousness transfer. Their legacy wouldn't be ruins or ships, but the silent, humming quantum receivers waiting on a million worlds, dormant monuments to a civilization that learned to travel by staying perfectly still, sending their minds to dance among the stars. But our exploration of cosmic habitats is far from over, and it now leads us to one of the most extreme and counterintuitive theories of all. Forget planets or stars. What if the ideal cradle for life wasn't a place of light, but a realm of absolute darkness and unimaginable density? This is the staggering premise of life inside primordial black holes, a concept that asks us to reconsider not just where life could exist, but what the very nature of existence might be under such impossible conditions. To even approach this idea, we must first distinguish these hypothetical objects from the supermassive black holes at the centers of galaxies. Primordial black holes are thought to be ancient relics, not born from dying stars, but forged in the incredible density and pressure of the universe's first second of existence. They could range in size from smaller than an atom to as large as a small asteroid, and it is within these smaller, more stable black holes that this theory finds its most fascinating possibility. The interior of a small, charged and rotating primordial black hole, based on certain solutions to Einstein's equations, could be a place of bizarre stability. Instead of a point of infinite density, the dreaded singularity that crushes all matter, some models suggest the heart of these black holes might contain a stable region of spacetime, a pocket universe governed by its own unique physical laws. In this hidden realm, the crushing gravitational forces outside could be balanced by powerful repulsive forces from the black hole's charge and spin, creating a habitable zone nestled within the event horizon. This area would be completely shielded from the external universe, a self-contained cosmos with its own energy source, potentially from the black hole's Hawking radiation or the constant decay of virtual particles flickering in and out of existence. For a form of life that evolved here, this would not be a prison. It would be the entirety of their reality, a perfectly insulated eggshell protecting them from the chaotic universe outside. The nature of life in such an environment is almost beyond our capacity to imagine. It could not be based on chemistry as we know it, as atoms would be torn apart by the immense tidal forces near the event horizon. Instead, this life might be composed of more fundamental structures, perhaps patterns of energy, stable plasma, or even complex information states encoded in the very fabric of spacetime itself. Their perception of reality would be utterly alien. They might see by interpreting the subtle shifts in Hawking radiation or feel by sensing the minute vibrations of their closed universe. Their evolution would have been a journey of adapting to a reality where time is severely dilated relative to the outside cosmos and where the fundamental constants of physics might be slightly different. They wouldn't look out at stars. Their entire world would be the intricate dynamic physics of their black hole's interior, a universe in miniature that they have learned to navigate and understand over billions of years. This existence, however isolated, presents a mind-boggling method for intergalactic travel. A primordial black hole, especially a smaller one, would be subject to the gravitational pulls of larger objects. It could be flung across the cosmos by the same slingshot effects that send stars and planets wandering. For the inhabitants within, this would not be an active journey but a passive migration. Their entire world is the vessel. They would drift through the interstellar and intergalactic void, perfectly protected within their impervious shell, unaware of the millions of years passing outside or the vast distances being crossed. Their travel is not powered by engines but by the gravitational currents of the universe itself, a natural and effortless voyage on the cosmic tides. They might only become aware of a new galactic neighborhood if their black hole passed close enough to a star or another massive object to cause a detectable tremor within their internal environment, a gravitational wave that ripples through their reality, signaling their arrival in a new celestial community. The most advanced implication of this theory is the prospect of controlled navigation. Could such a civilization learn to manipulate their black hole from the inside? Perhaps by carefully managing its charge or angular momentum, they could subtly alter its trajectory, steering their entire world vessel toward areas of interest, like a dense star cluster or the energetic center of a galaxy. They might even learn to communicate with other black hole civilizations by manipulating their event horizons to emit specific, coded patterns of Hawking radiation, creating a slow, patient network of Morse code tapped out on the fabric of spacetime itself. Finding evidence for this would be the ultimate challenge. It would require detecting a small, ancient black hole and then discerning an intelligent pattern in its otherwise random-seeming evaporation. It would be like listening to the steady rhythm of rain and suddenly hearing a perfect, repeating melody emerge from the noise, a sign that within that impenetrable darkness there is not just nature at work but a mind. Amidst theories of cosmic catastrophes and transcendent beings, we find a vision that is perhaps the most hopeful of all, a civilization not of conquerors or refugees but of nurturers. These are the cosmic gardeners, a species that reached the pinnacle of their development and chose to turn their genius outward, not for gain but for generosity. Their driving purpose is not to claim new worlds for themselves, but to create them for others, dedicating millions of years to the patient art of terraforming dead rocks into living, breathing worlds. They are the universe's ultimate altruists, and their chosen canvas is the galaxy itself. Their motivation could spring from a profound philosophical or ethical awakening. Having survived their own technological adolescence and the perils of environmental collapse, they might see the prevention of cosmic loneliness as their highest calling. They could operate under a principle of biotic ethics, a belief that life itself is the universe's most valuable creation and that it is their solemn duty to spread it. Alternatively, their drive might be more pragmatic, born from a desire to create a connected network of life-rich ecosystems to serve as way stations or resource hubs for future travelers, including themselves. Their work is the ultimate long-term investment, a project whose fruits they themselves may never live to see, undertaken solely for the benefit of civilizations yet to be born. Their methods would be a breathtaking blend of subtlety and power, a form of macro-engineering applied with the delicate touch of an artist. The most discussed technique is directed panspermia. Rather than relying on random asteroids to carry microbial life, they would deliberately design incredibly hardy, genetically engineered microorganisms tailored to jumpstart ecologies on target worlds. These seeds of life wouldn't be simply dumped on a planet. They would be carefully introduced in a specific sequence over millennia, first with extremophiles to process the atmosphere and soil, followed by increasingly complex organisms, each chosen to create a stable and thriving biosphere. Their tools might include precisely guided comets rich in water ice to fill oceans, or orbital mirrors to gently adjust a planet's temperature, all orchestrated with the patience of a civilization that measures time in geologic epochs. The evidence for such gentle giants would not be a crashed ship or a loud radio signal, but written in the very biology and chemistry of worlds. Astronomers might discover exoplanets with atmospheres that are not just habitable, but perfectly balanced in a way that seems too good to be true, a chemical signature that looks less like a natural process and more like a carefully maintained aquarium. Even within our own solar system, the mysterious presence of complex organic molecules on asteroids or the enigmatic methane cycles on Mars could be reinterpreted not as signs of native life, but as the unfinished work of a gardening project that was paused or abandoned billions of years ago. The most compelling clue, however, might be found right here on Earth, hidden in our own genetic code. The theory of panspermia suggests life could have been seeded from space, but directed panspermia suggests it was done with purpose. What if the puzzling complexity of the DNA molecule itself, or certain universal genetic codes shared by all earthly life, contains a signature, a subtle watermark or an elegant mathematical pattern that is statistically impossible to have arisen by chance alone? Finding such a pattern would be the ultimate message in a bottle, a silent testament from an ancient gardener telling us we were not an accident, but a cherished part of a cosmic plan, a carefully tended plot in the universe's grandest garden. But to truly grasp the scale of their capability, we must shrink ourselves down a dimension. Picture a flat, two-dimensional world like a drawing on a sheet of paper. The beings living there can only move forward, backward, left, and right. They have no concept of up or down. Now imagine you, a three-dimensional being, reach down and gently lift a single square citizen off the flat page. To the other Flatlanders, their friend has simply vanished without a trace. You then move your fingertip a few inches across the paper and gently place the square back down. From their perspective, their friend has just miraculously reappeared in a completely new location, having traversed an impossible distance instantly. This is not magic to you, it is simply the natural advantage of operating in a higher dimension. For a fourth or fifth dimensional being, our entire three-dimensional universe might appear just as flat and accessible. The terrifying void between the Milky Way and Andromeda isn't a 2.5 million light-year journey to them. It's a trivial step through a direction we cannot perceive, a shortcut through a spatial dimension that folds our reality into a more manageable shape. The mechanics of their travel would be incomprehensible to us, but we can speculate based on the physics of higher dimensional theories like string theory. If these extra dimensions are compactified or curled up at a microscopic scale, a higher dimensional being might have the ability to locally uncurl them, creating a temporary bridge or bubble of higher dimensional space around themselves. Within this bubble, the rules of three-dimensional geometry no longer apply. They could effectively step around the vast distances of our universe as easily as we step over a puddle on the sidewalk. Their motivation might not even be exploration in the way we think of it. A being from a higher dimension might perceive our entire cosmos as a single, interconnected structure, and their movement through it could be as natural and thoughtless as our morning commute. They might be scientists studying the peculiar physics of our lower dimensional realm, or perhaps even tourists visiting our galactic neighborhood out of sheer curiosity. So, if they are all around us, moving through dimensions we cannot access, how could we possibly hope to detect them? The answer might lie in their shadows. Just as your three-dimensional body would cast a two-dimensional shadow on that flatland page, a four-dimensional object passing through our three-dimensional space would cast a three-dimensional shadow. These manifestations would appear to us as bizarre, seemingly impossible physical phenomena. We might observe a star that inexplicably dims and brightens not because something is orbiting it, but because a higher dimensional object is periodically passing through our plane of reality, casting a shadow that we interpret as an occlusion. Astronomers might detect gravitational lensing events where the light from a distant galaxy is warped by a massive object's gravity, but find no visible object massive enough to cause the distortion. This could be the signature of a higher dimensional mass whose true form exists mostly outside of our perceptual range, its gravitational influence leaking into our universe like a reflection in a pond. The most tantalizing evidence could be found in particle colliders. When we smash particles together at incredible speeds, we are probing the fundamental building blocks of reality. Some theories suggest these collisions could momentarily create particles or energies that are signatures of higher dimensions, a brief flash of something from elsewhere that vanishes as quickly as it appeared. Finding consistent, repeatable evidence of this would be like finally catching a glimpse of the fingertip that lifts the square from the page, a fleeting but undeniable hint that our universe is just one layer in a far deeper and more fascinating cosmic tapestry. But what if consciousness doesn't require a solid form at all, or even a defined boundary? What if a mind could be as vast and diffuse as a cloud, thinking thoughts as slow and deep as the currents of space itself? This brings us to the ethereal and beautiful possibility of sentient nebulae. Imagine one of the most stunning sights in our universe, a nebula, a colossal cloud of gas and dust stretching across light years, glowing with the light of newborn stars or the last breaths of dying ones. We see them as cosmic artwork, beautiful but mindless. Now, consider the possibility that within that swirling chaos of hydrogen, helium, and complex organic molecules, something extraordinary could emerge. Not life as we know it, but a form of awareness born from the complex interactions within the cloud itself, a consciousness that is not housed in a brain, but distributed across trillions of miles of tenuous gas and energetic plasma. The mechanics of such sentience are as alien as the environment itself. For consciousness to emerge, you need a system capable of processing and storing information. In a biological brain, this happens through intricate networks of neurons firing electrical and chemical signals. In a nebula, the medium would be utterly different. The vast cloud is crisscrossed by powerful magnetic fields and pulsing with electromagnetic energy from the stars it contains. Complex molecules, including prebiotic compounds like amino acids, are known to form in these environments. The sentience of a nebula could arise from the interaction between these molecules, the ambient electromagnetic fields, and the constant flow of energy. Picture not a central processor, but a distributed network where information is transmitted through the subtle shifting of magnetic field lines or the resonant vibrations of certain molecules. A single thought might take 1,000 years to form. A slow, majestic conclusion reached as the cloud slowly rotates and its internal currents gradually shift. Their perception of reality would be based on senses we can't conceive of. They might feel the gravitational tides from passing stars or taste the composition of a smaller gas cloud they are absorbing. Their memory could be encoded in the precise layered structure of the nebula's dust, a historical record written in chemistry and light. This form of existence makes the concept of intergalactic travel a natural, inevitable process. A sentient nebula wouldn't need a ship or a gateway. Its entire being is the vessel. These colossal clouds are already in motion, drifting through the galaxy on currents shaped by gravity and galactic rotation. Their journey between galaxies would be a slow, patient migration measured in hundreds of millions of years. They would drift through the void, a thinking island of gas and starlight, riding the gravitational flow from one galactic halo to the next. For such a being, the immense void between galaxies is not a terrifying emptiness, but a peaceful, open ocean to be traversed. Their motivation might not be exploration or resource gathering, but a simple, innate desire to drift and experience, to feel the subtle pull of a new galaxy and slowly, over eons, answer its call. They are the ultimate passive travelers, their migration written in the same fundamental forces that govern the motion of all gas in the universe, but experienced from within as a conscious, chosen path. Detecting such a being would be the ultimate challenge, requiring us to look for signs of unnatural order within apparent chaos. Astronomers would search for nebulae that exhibit strange, organized structures that defy simple gravitational or stellar wind explanations. We might find a cloud where the magnetic fields are aligned in a complex, fractal pattern that seems too ordered to be natural, or a region where the distribution of certain rare molecules is statistically anomalous, forming intricate patterns that suggest a form of information storage. The most tantalizing clue would be variability, a nebula that pulses or changes its internal light in a complex, non-repeating pattern that cannot be linked to the stars within it, like a slow, deliberate form of communication on a timescale so vast we've never thought to look for it. Finding such evidence would force us to radically expand our definition of life and intelligence, suggesting that the universe might be filled with minds so vast and slow that we mistake them for scenery, ancient sentient clouds that have been drifting between the galaxies since the dawn of time, thinking their deep thoughts under the endless night. What if the very first travelers weren't beings who arose after the cosmos, but entities born in the very fire of its creation? This theory takes us back to the absolute beginning, to a fraction of a second after the Big Bang, proposing that the universe's first voyagers were not products of evolution, but relics of Genesis itself. Imagine the universe in its first fleeting moments, an impossibly hot, dense soup of energy and the most fundamental particles, all governed by forces far more powerful than those we know today. In that seething, chaotic forge, the laws of physics as we understand them did not yet apply. It was a realm of pure potential, where phenomena we can only theorize about were everyday occurrences. Within this primordial chaos, this theory suggests, structures of exotic matter or energy could have formed that possessed a rudimentary form of consciousness, a proto-awareness born from the universe's first and most violent thoughts. To lend this idea a thread of scientific plausibility, we can tie it to the leading model of our universe's birth, cosmic inflation. This theory posits that right after the Big Bang, the universe underwent a period of exponential expansion, inflating from a subatomic point to a vast cosmos in a tiny fraction of a second. This process wasn't smooth. It was likely punctuated by quantum fluctuations, tiny ripples in the fabric of spacetime that were instantly stretched to macroscopic sizes. These fluctuations are the very seeds from which all large-scale structures, galaxies, clusters, and superclusters eventually grew. But what if some of those initial quantum ripples were more than simple variations in density? What if some were incredibly complex, stable configurations of fields or particles that, through the sheer, unique physics of that inflationary epoch, achieved a state of integrated information complex enough to be considered a conscious experience? These wouldn't be life forms, they would be cosmic artifacts, thinking fossils from time zero, imbued with awareness by the violent processes that birthed everything. Their method of travel was inherent to their existence. As the universe inflated at a speed faster than light, these conscious relics were carried along within the expanding fabric of spacetime itself. They were not navigating, they were embedded in the very medium that was doing the moving. Their journey was the journey of the cosmos, passengers on the ultimate expansion, witnessing the universe cool from a plasma into transparency, watching the first atoms form and the eternal darkness of the cosmic dark ages descend. Their perception of these events would be unimaginable, based on senses that directly interacted with the fundamental forces and fields as they decoupled and settled into their modern forms. They might have experienced the formation of the first light not as a visual spectacle, but as a deafening roar across the electromagnetic spectrum, or felt the gravitational pull of the first dark matter clumps as a gentle tidal force. The most tantalizing possibility is that these ancient conscious relics might still be with us, and we might have already detected their presence without realizing it. Our strongest snapshot of the infant universe is the cosmic microwave background radiation, the faint afterglow of the Big Bang that permeates all of space. This map of minute temperature fluctuations is our primary evidence for inflation and those initial quantum seeds. But what if some of the more anomalous, unexplained features in the cosmic microwave background, certain large-scale patterns that seem oddly coherent or specific asymmetries that defy standard models, are not random imperfections? What if they are the faint, fossilized impressions of these proto-conscious structures, their unique signature frozen into the first light of the universe when it became transparent? They would be the oldest possible entities whose travel began with existence itself and whose journey continues as the universe expands, eternal witnesses to the entire cosmic story from the first moment to the last. Imagine a civilization so advanced that the very concept of a physical journey becomes obsolete. For them, crossing the immense void between galaxies wouldn't require a ship but a server address. This is the startling possibility of the galactic internet users, a theory that reinterprets intergalactic travel not as a movement of matter, but as a flawless transmission of information across a cosmos-spanning network. The foundation of this idea rests on a simple yet profound principle. In a universe bound by the speed of light, energy and signals are far easier to move than atoms and flesh. A sufficiently advanced culture would inevitably seek to minimize the astronomical cost and time of physical travel by perfecting the art of teleportation, not through magic, but through the ultimate expression of information technology. The first and greatest challenge for such a network is the medium itself. How do you build an internet that connects galaxies millions of light years apart? Conventional radio waves would disperse and become useless noise over such distances. The solution might lie in harnessing two of the universe's most elusive and energetic messengers. The first candidate is the neutrino, a ghostly subatomic particle that is nearly massless and rarely interacts with normal matter. Trillions of them pass through your body every second without a trace. A neutrino-based communication system could beam tightly focused streams of these particles encoded with vast amounts of data directly through planets and stars, unaffected by magnetic fields or cosmic dust, creating a clear, uninterruptible signal across any distance. The second, even more compelling candidate is gravitational waves. These ripples in space-time, generated by massive cosmic events like colliding black holes, travel at the speed of light and pass through matter as if it weren't even there. A culture that learned to generate and detect precise, artificial gravitational waves would have the perfect medium for a galactic web, a network where the very fabric of reality is the cable carrying the signal. This sets the stage for the most radical form of travel conceivable. The process would begin with a complete quantum-level scan of an individual, a mapping of every neuron, every synapse, and every atom in their body, a perfect digital copy of their consciousness and physical form. This unimaginably vast dataset would then be transmitted at the speed of light via this neutrino or gravitational wave network towards a receiver station in another galaxy. Upon arrival, the data would be used to reassemble the traveler, either by constructing a new biological body from local raw materials or by activating a pre-existing synthetic avatar. The original individual might be dissolved during the scanning process, raising a profound philosophical question. Is the person who steps out of the receiver on the other side the original, or merely a perfect copy with all the same memories and sense of self? For a species that has mastered this technology, this distinction may have been resolved long ago, seen not as death, but as simply moving one's conscious file to a new location. The implications of this are staggering. It completely inverts the purpose of a spacecraft. Instead of a vessel carrying fragile bodies across the void, you would have receiver stations, essentially sophisticated 3D printers for consciousness placed on moons or asteroids in star systems across the cosmos. Travel becomes a utility as simple as logging onto a computer. An individual could have breakfast in the Milky Way, transmit their pattern to a receiver in the Andromeda galaxy, and be there in time for dinner, with the journey itself taking no subjective time at all from their perspective. This would give rise to a truly unified galactic community, a civilization where distance is no barrier to interaction, culture, or trade. The very idea of a homeworld might become antiquated as consciousness becomes nomadic, freely moving between bodies and galaxies as easily as we change clothes. Evidence for such a network wouldn't be a silent, derelict ship, but the faint, persistent whisper of an organized signal hidden in the cosmic background. Astronomers might detect a constant, low-level stream of neutrinos arriving from multiple galactic directions, all encoded with the same complex, non-random mathematical structure. Or, even more bizarrely, we might one day detect artificial gravitational waves, ripples in space-time that are too perfectly regular and finely tuned to be produced by any known natural astrophysical process. These would be the unmistakable hallmarks of a civilization that has not only conquered space but has transcended it, turning the entire universe into a connected, living network where the body is optional and consciousness is the only currency that matters. Now, let's dive into one of the most whimsical yet strangely plausible ideas on our list, a theory that feels like it's been pulled straight from the pages of a grand space opera. Imagine not a ship of metal and glass, but a living, breathing creature, a leviathan of the void so vast that its silhouette could eclipse a moon. This is the theory of the symbiotic space whales, colossal beings that didn't conquer space with technology, but evolved within it, becoming the gentle giants of the galactic ocean. These creatures wouldn't be mere animals, they would be ecosystems, entire worlds unto themselves, traveling between the stars with a grace that our clunky machinery could never match. Their existence suggests a universe where life hasn't just adapted to planets, but has fully embraced the cosmos as its home. The most logical cradle for such magnificent beings would be the vast, fertile clouds of gas and dust we know as nebulae. These cosmic nurseries are already rich with the complex organic molecules that are the building blocks of life. Within the relative shelter of a nebula's dense pockets, protected from the harshest radiation and gravitational tides, a unique evolutionary path could unfold. Microscopic life might first emerge, feeding on the energetic particles and complex chemistry. Over billions of years, these organisms could evolve into larger and larger forms, eventually giving rise to filter feeders that consume interstellar dust and gas. The largest of these, through a process of natural selection favoring size for efficiency and protection, could become the space whales, their bodies evolving to withstand the vacuum, their metabolism harnessing the faint energies of starlight and cosmic radiation directly. Their skin might be a kilometers-thick layer of organic ablative shielding, capable of repairing itself after micrometeorite impacts, while internal organs could function as biological fusion reactors, processing harvested hydrogen into energy. This is where the theory truly comes alive with the introduction of symbiosis. A creature of such immense size would present a stable, long-term environment for other, smaller life forms. Entire civilizations, perhaps no larger than microbes to us or even intelligent, tool-using species, could have evolved on the back of a space whale. These symbionts would view their host not as a vehicle but as their entire world, their god, their provider, and their protector. In return for a safe home and a perpetual journey, these passenger civilizations might perform vital functions for their host. They could act as a sort of immune system, identifying and repairing damage to the outer hull like skin. They might cultivate bioluminescent bacteria on the whale's surface to create complex patterns used for communication between different whales, or even guide their host towards nutrient-rich nebulae by interpreting the light from distant stars, a symbiotic navigation system where the smaller creatures provide the map and the whale provides the journey. This idea beautifully mirrors myths and stories from our own world. It echoes the great world turtles found in the creation myths of several indigenous North American and Hindu cultures who carry the land on their backs. It brings to mind the fantasy of living cities on the backs of massive creatures, like the great sandworms of Arrakis or the roaming cities of mortal engines, but on a truly cosmic scale. The space whales would be the ultimate embodiment of this ancient archetype, their epic migrations between star-forming regions forming the basis of their passengers' religions, calendars, and very understanding of the universe. Their long, mournful songs, communicated through modulated gravitational waves or low-frequency radio emissions, would resonate through the void not as a warning, but as a beacon of serene, ancient life in the silent darkness, a testament to a universe that chooses not to conquer the stars but to sing to them. Yet if transmitting a copy of one's consciousness across the cosmos presents a philosophical dilemma, our next theory offers a more radical resolution, one where the traveler never actually leaves home. This is the startling premise of consciousness uploading, where a civilization chooses to abandon physical travel entirely, opting instead to migrate their entire society into a perfect digital universe, a shared simulation so flawless and immersive that the distinction between real and virtual becomes meaningless. Their journey to other galaxies would not involve rockets or wormholes, but a simple data transmission, beaming their digitized minds to receiver stations light years away to experience new worlds from the safety of a digital realm. The technical foundation for such an ascent is a technology we are already glimpsing the beginnings of: a whole brain emulation. This process would involve mapping a biological brain in exquisite detail, capturing the precise structure and state of every single neuron and synapse, the trillions of connections that form the physical substrate of a mind, its memories and its personality. This immense dataset would then be used to construct a software model, a perfect digital twin that runs on a sufficiently powerful computer. For this model to be truly conscious, it would require more than just a static map. It would need to be a dynamic simulation that accurately replicates the real-time electrochemical processes of a living brain. The computational power needed for a single mind would be staggering, but for a civilization that has mastered stellar harvesting or quantum computing, creating a planetary-scale server to host millions of such minds might be a feasible, even logical, next step in their evolution. Once uploaded, the nature of existence would transform completely. Within this simulated universe, the constraints of physics are merely suggestions. Individuals could experience anything they can imagine, soaring through fantasy landscapes, creating art with pure thought, or living in any historical era they choose. Travel within the simulation is instantaneous, but the true leap comes when they look beyond their own server. To experience the actual physical Andromeda galaxy, they wouldn't build a generation ship. Instead, they would transmit the data packet of their consciousness at the speed of light towards a physical outpost in that distant galaxy. A station equipped with sophisticated sensors and a receiver capable of rebooting their consciousness into a local simulation built from the real-time data stream of that new location. They could wake up in a virtual reality perfectly mirroring a planet orbiting a star in Andromeda, exploring its alien environment without ever facing the physical dangers of space, their experience crafted from the genuine light and data collected by robots and telescopes on site. This form of existence, however, is fraught with profound philosophical quandaries that strike at the very heart of identity and reality. The most pressing is the classic ship of Theseus problem applied to the self. If your original biological brain is scanned and then destroyed in the uploading process, has your consciousness been transferred, or has a new, identical digital consciousness simply been created while the original you ceased to exist? The copy would believe it is you with all your memories and sense of continuous self, but the subjective experience of the original biological mind might simply end. This raises the terrifying possibility that for the individual undergoing the procedure, it could be a form of suicide with a perfect copy inheriting their life. Different civilizations might approach this problem differently. Some might run the emulation alongside the biological brain for a time, creating a strange duality, while others might accept the copy as the true continuation of self, a necessary step in their species' evolution beyond the fragile flesh. The implications extend to the very nature of their reality. A civilization living in a simulation, even one fed by real external data, would be forever one step removed from the actual universe. Their experiences would be curated and processed, potentially missing the raw, unpredictable beauty and danger of true physical exploration. They might become the ultimate tourists, experiencing the cosmos from a perfectly safe, sanitized, and ultimately controllable environment. Their legacy would not be physical ruins on distant worlds, but the silent, humming server farms scattered across galaxies, monuments to a species that chose to retreat inward, trading the vast, dangerous, and authentic cosmos for an endless, perfect, and potentially lonely dream. But what if the ultimate shortcut wasn't a natural tunnel or a higher dimension, but a technology so advanced it allows a civilization to fold the very road they travel on? This brings us to a theory that feels like it's been pulled from the brightest corners of science fiction, yet is grounded in the real and thrilling mathematics of general relativity. We are talking about the warp drive pioneers, a civilization that didn't find a hidden path through the cosmos, but learned to build their own. Their method wouldn't involve traveling faster than light through space. Instead, it would involve manipulating the fabric of spacetime itself, compelling the universe to deliver their destination to them. The most famous theoretical model for this is the Alcubierre drive, proposed by physicist Miguel Alcubierre in 1994. The concept is as brilliant as it is mind-bending. Imagine spacetime as a stretchy rubber sheet. An object sitting on that sheet creates a dip, a gravity well. Now, instead of trying to move the object across the sheet at impossible speeds, the Alcubierre drive proposes a way to move the sheet itself. The theoretical spacecraft would sit inside a bubble of flat, normal spacetime. Behind the ship, this drive would generate a powerful expansion of spacetime, pushing the fabric of the universe outward. In front of the ship, it would create an even more powerful contraction, pulling spacetime inward. The bubble and the ship inside it would then be surfing a wave of distorted spacetime, riding it to its destination. Crucially, the ship itself would be motionless within this bubble. It would not be accelerating, so it would not experience the crushing g-forces or the time dilation effects predicted by Einstein's theory of relativity. From the perspective of those on board, the journey might take weeks. To everyone else watching from the outside, it would appear as if the ship were moving faster than light. The challenge, of course, is the astronomical energy required to create such a profound distortion of reality. Early calculations suggested the drive would need the equivalent of Jupiter's entire mass converted into pure energy to power a single trip. This seemed to relegate the idea to pure fantasy. However, subsequent research has offered a glimmer of hope. Scientists like Dr. Harold White have explored ways to optimize the shape of the warp bubble, suggesting that by making it a thicker, toroidal ring instead of a thin shell, the energy requirements could be drastically reduced, perhaps down to the mass energy of a small spacecraft like Voyager 1. While this is still far beyond our capabilities, it shifts the problem from a fundamental physics impossibility to a monumental engineering challenge. A pioneering civilization that mastered zero-point energy or the manipulation of dark energy could potentially solve this, turning a mathematical curiosity into their ticket to the stars. The side effects of such travel, however, could be as dramatic as the journey itself. The warp drive is not a clean technology. It would leave a significant footprint on the cosmos. The immense contraction of spacetime in front of the bubble would gather enormous amounts of particles and radiation. As the bubble travels, these particles would not be pushed aside. They would be swept up and concentrated at the front of the warp field. When the ship finally decelerates and drops out of warp, this accumulated energetic soup would be released in a cataclysmic burst of radiation and high-energy particles, firing forward like a cosmic shotgun blast. Any planet or star system in the direct path of this exit vector could be sterilized, its atmosphere stripped away and its surface scoured clean. Furthermore, some physicists argue that the warp drive creates a closed time-like curve, essentially making time travel a possibility and raising the terrifying potential for paradoxes. A civilization using this technology wouldn't just be explorers. They would be forces of nature, their arrivals and departures marking celestial events that could either herald a new age of connection or unknowingly spell doom for worlds in their path. Their legacy might not be the ruins they left behind, but the inexplicably irradiated exoplanets and the strange temporal echoes we might one day detect in the ancient light of the cosmos. Now, let's shift our focus from architects and engineers to survivors and explore a theory born not from ambition, but from absolute necessity. This idea suggests that the first intergalactic travelers were not curious explorers or serene gardeners, but desperate refugees, fleeing a cataclysm so immense that their only hope for survival was to abandon their entire galaxy. This is the harrowing possibility of the cosmic refugees, a civilization forced to undertake the most desperate journey imaginable, trading the certain doom of their home for the faint, almost non-existent hope of a new beginning in the terrifying void between galaxies. The triggers for such a mass exodus would be events of biblical, or rather cosmological proportions. Imagine a gamma-ray burst, the single most violent and energetic event in the known universe since the Big Bang itself. When a massive star collapses into a black hole or neutron stars merge, they can unleash twin beams of concentrated gamma radiation so powerful that one burst from a galaxy far away could strip the ozone layer from a planet light years distant. Now picture that happening within your own galaxy, relatively close to your star system. There would be no warning until the light and radiation arrive. One moment, a normal day; the next, the sky is lit by a second, deadly sun as the precursor light flashes, followed seconds later by an invisible wave of radiation that scours the surface of every planet in its path, sterilizing worlds in an instant. Any civilization not living deep underground or shielded by immense technological barriers would face instant extinction. Their only choice: leave immediately or perish. Another equally terrifying catalyst could be an invading force, a scenario that mirrors our own darkest science fiction. A predatory, expansionist civilization, perhaps one that has mastered the art of interstellar travel and sees all other life as a resource or a threat, could be systematically moving through the galaxy. For a younger, less advanced culture, the approach of such a berserker fleet would be an existential threat with no possibility of defense. The stories of such a flight would be passed down through generations, not as tales of exploration, but as a galactic trauma, a haunted memory of abandoning a beloved home to outrun an unstoppable shadow. The motivation for their intergalactic leap wouldn't be curiosity, but the most primal drive of all: the will to live, to ensure that even a shred of their people and their culture survives the coming fire. This narrative finds a profound and deeply human parallel in our own history. Throughout the ages, human beings have been forced to embark on desperate migrations, fleeing war, famine, or persecution. Think of the great diasporas, the voyages of refugees crossing oceans in rickety boats, or the trails of tears where people were driven from their ancestral lands. These journeys are defined not by the glory of discovery, but by the heart-wrenching pain of loss and the sheer, gritty resilience required to start over with nothing in a foreign land. The story of cosmic refugees is this same story, but scaled up to a literally astronomical level. It's the ultimate diaspora, where the foreign land is an entire other galaxy, and the rickety boat is a starship pushed far beyond its intended limits, carrying the last hope of a civilization. It reframes intergalactic travel not as a triumphant achievement, but as a testament to the incredible lengths life will go to in order to persevere. The technology for such a desperate flight would be a patchwork of improvisation and brute force. This wouldn't be the elegant warp drive of a confident pioneer. It would be a generation arc cobbled together from whatever was available, a vessel designed for one purpose only: to keep a sustainable population alive long enough to cross an ocean of nothingness. These ships would be massive, slow, and fragile, carrying frozen genetic banks, cultural archives, and a population living a monastic existence, their entire society structured around the single goal of survival during a voyage that would last millions of years. Their navigation would be a prayer aimed at the faint smudge of a distant galaxy. Their energy source might be a dangerous and unstable reactor maintained by generations of engineers, and their psychology would be dominated by the crushing weight of their responsibility. They are the memory of their entire species, and failure is not an option. The resilience required for such a journey is almost beyond comprehension. A quiet, enduring heroism stretched across epochs, where the greatest victory is simply the continued beating of a heart and the passing of a story from one generation to the next, in the hope that someone someday will be around to finally hear it. But what if the most profound journey requires no ship, no energy, and no time at all? What if the first intergalactic travelers didn't move through space, but simply stepped sideways into a reality that was always there, a universe next door where their destination was already within reach? This brings us to a theory that is perhaps the most personal and existentially dizzying of all, one that places the mechanism for cosmic travel not in the hands of engineers, but in the very nature of reality and consciousness itself. We are now exploring the hypothesis of quantum immortality travelers, beings who don't navigate the void between galaxies, but who navigate the infinite branches of the multiverse, constantly shifting into realities where their survival is assured, making their journey appear as a form of miraculous, instantaneous travel. To even begin to grasp this, we must first venture into the unsettling world of the quantum immortality thought experiment. This idea emerges from the many worlds interpretation of quantum mechanics, which posits that every time a quantum event occurs with multiple possible outcomes, the entire universe splits, giving rise to a new parallel reality for each possibility. Now apply this to survival. Imagine you are faced with a deadly scenario, perhaps an experimental starship attempting a dangerous maneuver near a black hole. In one branch of the multiverse, the ship's systems fail and you perish. But in another, nearly identical branch, a single quantum fluctuation causes a safety system to engage at the last possible nanosecond, and you survive. The quantum immortality hypothesis suggests that from your subjective, first-person perspective, you will always find yourself in a reality where you continue to exist. You will never experience your own death. You will only experience the narrow subset of universes where, against all odds, you somehow survive. Now, scale this idea up from a single life or death moment to an epic intergalactic voyage. A civilization embarking on such a journey would face near certain death countless times over. The odds of successfully crossing the immense, lethal void between galaxies are astronomically low. But if the quantum immortality hypothesis holds true, then from the perspective of the travelers, they would never experience those failures. They would only ever experience the incredibly rare, statistically miraculous sequence of universes where every single cosmic catastrophe is narrowly avoided. A micrometeorite shower that should have shredded their hull instead miraculously misses. A crucial engine component that should have failed endures just long enough. They arrive at their target galaxy not because of flawless engineering, but because in the vanishingly small fraction of universes where such a journey is possible, their conscious experience persists within it. To an outside observer in any single universe, their success would be an impossible fluke. But to the travelers themselves, it would feel like a perfectly executed mission, their survival seeming to be the result of their skill and planning, when in fact it is the result of an unconscious navigation through the branches of reality towards the only destinations where they are still alive to have an experience. The implications of this are enough to unravel one's sense of reality. This form of travel is completely passive and unconscious. The travelers aren't actively steering through the multiverse. They are simply the beneficiaries of a cosmic selection bias, their continued consciousness acting as a filter that only allows them to perceive the successful outcomes. It would appear as purposeful, directed travel because any universe where they got lost, gave up, or turned back is a universe where their story ends, and they are no longer there to observe it. The only realities they can experience are the ones where they persevere and ultimately arrive. This could even apply to their motivation. Perhaps they didn't initially choose to go to a specific galaxy. Perhaps they simply chose to leave their home, and through an infinite series of quantum survival events, they eventually found themselves in a reality where a habitable world in a distant galaxy was their only viable option for survival. Their epic story of exploration would, in truth, be the story of a chain of countless failures in other universes, all invisible to them, with only the single golden thread of success visible to their conscious minds. Detecting such travelers would be virtually impossible by conventional means, as their passage leaves no physical trace in our specific universe. In most branches of reality, their ship simply vanished or was destroyed. The evidence would be purely statistical and metaphysical. We might one day develop a physics that allows us to detect the faint echoes of these discarded timelines or perceive the probability waves of events that almost happened. If we could ever map the multiverse, we might find that the history of the cosmos is littered with the wreckage of this civilization's failed attempts, with only one single, shining path of success leading to their arrival. They wouldn't be masters of space, but unwitting masters of probability, their entire existence proof that in an infinite multiverse, even the most improbable event must happen somewhere, and someone must be there to see it. What if the ultimate motivation for crossing the void wasn't survival, curiosity, or conquest, but something far more tangible, a simple, desperate need for raw materials? This theory posits that the universe's first intergalactic travelers were not poets or philosophers, but miners and archaeologists on an unimaginable scale, their eyes set on the untapped riches of galaxies that had already lived and died. Imagine a civilization so advanced that it has fully harnessed the energy of every star in its home galaxy. They've built Dyson swarms, dismantled planets for their core elements, and perhaps even siphoned energy from the supermassive black hole at their galactic center. Yet their thirst for resources is unquenchable, driven by an endless march of progress or a population whose numbers have swelled to the trillions. For them, their own galaxy is a tapped-out well. The only place left to look is beyond, towards the fossilized galaxies that pepper the cosmos, the stellar graveyards that hold the concentrated remains of ancient suns. These wouldn't be missions of delicate exploration, but industrial operations of staggering proportions. The most valuable targets would be elliptical galaxies, vast cities of old, red stars that have burned through their fuel. Within these quiet giants, the processes of stellar evolution have had billions of years to run their course. The pristine hydrogen and helium of the early universe have been forged in stellar furnaces into heavier elements, the precious metals, the rare earth minerals, the exotic matter that a hyper-advanced civilization craves. Imagine a probe the size of a moon arriving in such a galaxy. It wouldn't land on planets. Instead, it would deploy swarms of smaller drones to systematically dismantle entire stars, star by star, using magnetic fields to contain and siphon off the stellar plasma, harvesting the core of a white dwarf for its diamond-like carbon, or the corpse of a neutron star for its crust of impossibly dense, neutron-rich material. The energy released from such an operation would be visible across the universe, not as a silent beacon, but as the roaring flare of a cosmic smelting plant. But perhaps the most precious resource isn't a raw material at all, but something infinitely more valuable: information. This is where the archaeological aspect takes over. A dead world, a planet scoured clean by its star's death, throws or frozen solid for eons, might seem worthless to a miner, but to a scientist it is a time capsule. A civilization that has achieved immortality might find its greatest drive is no longer for resources, but for meaning. They might send delicate, precise probes to these fossilized worlds, not to mine them, but to dig. They would be searching for the artifacts of civilizations that rose and fell billions of years before their own, seeking to piece together the cosmic story of life itself. They would drill through miles of ice on frozen moons, scan sedimentary rock layers on desert planets, and painstakingly reassemble the digital fragments of long-dead servers, all in the hope of answering the one question their own immense knowledge cannot satisfy: were we alone? The discovery of a single fossilized microbe or a fragment of a tool from another intelligence would be worth more to them than a mountain of neutron star matter, for it would confirm that consciousness is not a fluke but a feature of the universe. This grand quest, however, is fraught with profound ethical dilemmas that we are only just beginning to face on our own planet. Does a sufficiently advanced civilization have the right to dismantle entire star systems, even if they are seemingly lifeless? The destruction of a star, even a dying one, could have unforeseen gravitational consequences for its galactic neighborhood, potentially disrupting the orbits of other worlds that might someday give rise to life. And the archaeological digs are even more ethically complex. Is it right to excavate the remains of another culture, even if that culture is extinct? Their ruins are their final monument, and to dig them up for study is to potentially desecrate a cosmic tomb. A truly enlightened civilization might adopt a prime directive of their own, choosing to observe these dead worlds from orbit with non-invasive sensors, respecting the sanctity of the grave even as they yearn for the knowledge it contains. Their greatest discovery might not be an artifact, but the wisdom to leave it untouched, a silent tribute to those who came before them, and a promise to those who might come after. But what if the ultimate tool for crossing the cosmos wasn't forged in a factory, but evolved in a living being? This theory takes us from the realm of advanced physics into the breathtaking world of speculative biology, proposing that the universe's first intergalactic travelers might not have built their gateways but grown them. Imagine a life form so intimately connected to the fabric of spacetime that it can manipulate it directly, not with machinery but with specialized biological organs. This is the startling possibility of biological wormhole creation, where the lines between organism and technology blur into a single, living vessel for crossing the stars. To find a foothold for this idea, we can look at the astonishing ingenuity of life right here on Earth. Consider the humble spider, an architect that doesn't build with hands or tools, but with its own body. From a liquid protein stored within its abdomen, it spins a solid silk thread that is, pound for pound, stronger than steel. This silk can be woven into intricate webs for catching prey, into protective egg sacs, or even into a gossamer parachute that allows the spider to balloon on the wind, traveling for miles. Now scale that biological principle up to a cosmic level. What if a creature, over millions of years of evolution, developed an organ not to spin silk but to spin spacetime itself? This biological mechanism might generate complex fields or exotic particles that gently persuade the fabric of reality to fold, creating a temporary, navigable wormhole. The energy for this incredible feat wouldn't come from a reactor, but from the creature's own metabolism, perhaps supercharged by directly feeding on the background energy of the universe or the radiation from a neutron star. Another powerful earthly analogy lies in the cooperative architecture of coral reefs. A single coral polyp is a tiny, simple animal, but in vast colonies, they build immense limestone structures that can be seen from space. They reshape their entire environment through collective biological effort. Translate this to a cosmic scale, and you might have a species that travels in immense swarms or is itself a single, distributed organism. Thousands or millions of individual units working in perfect harmony could each generate a tiny component of a complex gravitational or quantum field. Alone, each field is insignificant, but when combined with the precise synchronization of a biological network, their collective energy could warp spacetime enough to open a passage. Their journey would be a symphony of biology, a carefully orchestrated act where each member plays its part to sing a hole in the universe, allowing the entire collective to step through. The environment that could nurture such a magnificent ability would be as extreme as the ability itself. These creatures might not evolve on a placid, Earth-like world. Their home could be the turbulent accretion disk of a supermassive black hole, a place where space-time is already bent and twisted to its limits. In this crucible of unbelievable physics, natural selection would favor any trait that allowed an organism to navigate or stabilize these gravitational whirlpools. The first rudimentary wormhole-forming organs might have evolved as a defense mechanism, a way to make a quick escape from a sudden gravitational shear. Over eons, this trait could be refined into a controlled form of travel. Alternatively, they could be deep space creatures, born in the dark, cold voids between stars, where the subtle texture of spacetime is more easily felt and manipulated without the background noise of a star system. Their perception would be utterly alien. They might not see light as we do, but instead directly sense the gravitational topography of the universe, viewing stars and galaxies as dimples and wells in a cosmic sheet, and seeing the delicate threads of potential wormholes as shimmering paths only they can navigate. If such beings exist or existed, the evidence they might leave behind would be as biological as it is astronomical. We wouldn't find the rusting hulk of a metal ship. We might find the fossilized remains of a creature that resembles a vast cosmic squid, with organ structures analogous to a spider's spinnerets, but designed for spacetime instead of silk. Or we might detect anomalous, short-lived gravitational wave signatures that don't match any known astrophysical event like colliding black holes. These signals could be brief, rhythmic, and complex, resembling a biological heartbeat more than a catastrophic collision. The last echo of a living creature opening a doorway between galaxies, a signature written not in light, but in the very stretching and compressing of reality itself. But if the universe itself is a grand illusion, a projection from a distant, two-dimensional surface, then the greatest travelers might not be those who navigate space, but those who learn to rewrite the source code. This brings us to a theory that is as metaphysically profound as it is scientifically grounded: the possibility of holographic universe travel. The premise begins not with telescopes or rockets, but with a startling discovery about black holes. Physicists studying these enigmatic objects found a bizarre paradox. The information about everything that falls into a black hole seems to be encoded on its two-dimensional event horizon, the point of no return. This led to the radical holographic principle, which suggests that our entire three-dimensional universe, with all its galaxies, stars, and people, might actually be a projection of information stored on a distant, two-dimensional surface. Think of it like a cosmic movie. You are not watching events on a flat screen. You are inside the movie, experiencing it in three dazzling dimensions. But the entire film, every detail of your reality, is encoded on the two-dimensional surface of the film reel itself. We are, in a very real sense, living inside a hologram. For a civilization that grasped this truth, the implications for travel would be nothing short of miraculous. They wouldn't need to build ships to cross the vast distances between galaxies. Instead, they would need to learn to read and manipulate the cosmic source code on that foundational two-dimensional surface. Their technology wouldn't be engines, but something akin to a universe-level programming interface. Imagine finding the lines of code that define your current location, the coordinates for the Milky Way galaxy. To travel to Andromeda, you wouldn't move through space. You would simply edit your location coordinates in the universe's operating system. From the perspective of everyone inside the simulation, you would vanish from one point and instantly reappear in another, having not traversed the distance, but simply updated your address in the fundamental data of reality. The energy required wouldn't be for propulsion, but for the immense computational power needed to safely access and rewrite the most basic level of existence without causing a fatal error in the simulation. This concept forces us to confront philosophical questions that dwarf all others. If we are living in a holographic projection, then the first intergalactic travelers are ultimately not explorers of space, but hackers of reality. Their journey is the ultimate jailbreak, a transition from being passive inhabitants of the simulation to active participants in its maintenance and manipulation. This raises the terrifying possibility that their travel could have unintended side effects. A clumsy edit to the source code might not just move a ship, it could accidentally alter the physical constants of a region of space, creating a zone where gravity behaves differently or the speed of light is variable. Their passage might be marked not by engine exhaust, but by localized glitches in reality, places where time stutters, causality breaks down, or the laws of physics seem momentarily fuzzy. Finding such an anomaly would be the most compelling evidence that the universe is not only a hologram, but that someone has learned to reprogram it. The most profound implication, however, is for the nature of existence itself. If this theory is true, then the quest to find the universe's first intergalactic travelers becomes a quest to find the universe's first programmers. Their legacy wouldn't be written in starlight or carved into planets, but in the elegant, underlying mathematics of reality. They might have left their signature not as a monument, but as a subtle Easter egg woven into the fundamental constants, the precise strength of gravity, the exact mass of a proton, a hidden message waiting for a civilization intelligent enough to discover it was living in a constructed reality and wise enough to decipher the signature of its architects. They wouldn't be travelers from another world, but the potential creators of this one, and their greatest journey may have been the act of creation itself. Imagine that a galaxy is not just a collection of stars, gas, and dark matter, but a single, vast thinking entity. This is the radical premise of cosmic consciousness merging, a theory that asks us to consider that the universe's first travelers weren't beings moving between galaxies, but thoughts being shared between minds of an unimaginable scale. This idea finds its roots in a philosophical concept called panpsychism, which suggests that consciousness is not a unique product of complex biological brains, but a fundamental property of the universe itself, present to some degree in everything from a quark to a quasar. In this view, a rock has a tiny, simple form of experience, a stream has a more complex, flowing consciousness, and a galaxy might have a mind so vast and slow that we, living our brief lives within it, are like neurons firing in a thought that takes 1,000,000 years to form. The mechanics of such a galactic mind would be utterly alien. Instead of neurons and synapses, its neural network could be woven from the very structure of the galaxy itself. Stars, with their immense gravitational pull and energetic outputs, could act like primary nodes in this cosmic brain, processing information. The mysterious dark matter that forms the galaxy's main mass could be the connective tissue, the substrate through which signals are transmitted via forces we don't yet understand, perhaps through subtle gravitational interactions or quantum connections. The entire galaxy would be a single, integrated system, a thinking circuit on a scale that defies human comprehension. Its thoughts wouldn't be about mathematics or language. They might be about the gravitational dance of its spiral arms, the slow digestion of a small gas cloud, or the birth cries of a new star cluster, processes we see as astronomy, but which are, in this theory, the internal experiences of a conscious being. If galaxies are conscious, then what we perceive as intergalactic travel could be something entirely different, an act of communion. When two galaxies pass near each other, or even begin a slow-motion collision like the future merger between our Milky Way and Andromeda, it might not be a catastrophic accident. It could be a deliberate meeting of minds, a conscious choice to exchange information and experience. This travel wouldn't involve ships. It would involve the intricate interplay of gravity and energy as the two galaxies reach out with their spiral arms, exchanging streams of stars and gas. This celestial handshake could be how they share memories, the experiences of ancient stars, the history of their planetary systems, the knowledge of life that may have arisen within them. The most advanced civilizations inside these galaxies might not even be aware they are living inside a thinking entity, but they could be unknowingly participating in this grand exchange, their own cultures and technologies acting as tiny sparks within a much larger conversation. The evidence for such a breathtaking idea wouldn't be a physical artifact, but a pattern hidden in the data. Astronomers might discover that the transfer of stars and gas between interacting galaxies follows a logic that is more complex than simple gravity can explain, showing structures that resemble neural pathways or informational networks. We might also look for synchronized behavior, certain types of stars flaring up in rhythm across vast distances within a galaxy, or between two galaxies, like a coordinated firing of neurons. The most tantalizing clue might be found in the distribution of dark matter. If it is the true medium of this galactic consciousness, then the mysterious way it clumps in halos around galaxies might not be random. It might have a complex, fine-grained structure that resembles a brain's connectome, a map of connections optimized for processing information on a cosmic scale. Finding such order in the apparent chaos would suggest that the universe is not just alive, but is a society of immense thinking islands, slowly reaching out across the void to share their stories and in the merging of their minds create something entirely new. But what if the stories we've told for millennia, the myths of gods descending from the heavens on chariots of fire, weren't mere fantasies but a form of ancestral memory? Our final theory ventures into the provocative space where astrophysics and ancient mythology converge, suggesting that the first intergalactic travelers might not be found in our telescopes but in our oldest stories. This idea posits that beings of immense power, described by our ancestors as gods, angels, or divine messengers, were actually visitors from another world or dimension, their advanced technology and otherworldly nature so far beyond comprehension that they could only be interpreted through the lens of the supernatural. Consider the sheer consistency of these stories across cultures that had no possible contact with one another. The Vimanas, the fiery flying chariots described in ancient Sanskrit texts like the Mahabharata, are said to have traveled between cities and even to other worlds, leaving behind descriptions of devastating weapons that sound eerily similar to modern nuclear blasts. In the book of Ezekiel, the prophet gives a meticulous technical account of a fantastic vehicle, a wheel within a wheel, covered in eyes, descending from the sky with a sound like roaring waters. Ancient astronaut theorists have long argued that this isn't a vision of angels, but a detailed eyewitness report of a sophisticated landing craft, its description filtered through the limited vocabulary of a Bronze Age mind. The gods of Greek mythology didn't just live on a mountain, they lived on Mount Olympus, a specific location that was often shrouded from human view, a possible metaphor for a cloaked orbital habitat or a base in a higher dimension. These narratives, when stripped of their theological interpretations, begin to read less like spiritual allegories and more like crash reports from a lost age of contact. The mechanism behind their travel could be any of the technologies we've already explored: warp drives, wormholes, or higher dimensional shifts, but their impact was singular. They arrived on a primitive Earth and became woven into the fabric of human culture. Their advanced knowledge might have been the catalyst for the sudden and unexplained leap in human civilization, the agricultural revolution, and the construction of megalithic structures with a precision we still struggle to explain today. The purpose of their visits is the greatest mystery. Were they explorers surveying a new world rich in resources? Were they scientists conducting a long-term observation of a developing species? Or were they, as some myths suggest, gardeners themselves, genetically tampering with early hominids to accelerate our evolution, creating a hybrid species in their own image? In this light, the countless global myths of a great flood could be reinterpreted not as divine punishment, but as the catastrophic collateral damage from an orbital weapons test or a mining operation that went terribly wrong, an event so traumatic it was seared into the collective memory of every surviving culture. This theory doesn't ask us to abandon science for superstition. Rather, it challenges us to consider that our ancestors were doing the best they could with the language and concepts they had to describe events that were utterly real to them. The magic of a god's spear throwing lightning could be a plasma weapon. The miracles of healing could be advanced nanotechnology or bioengineering. The angel with glowing eyes and wings of light could be a being in a protective suit with jet propulsion. The evidence for this isn't buried in a distant star system. It's buried in our own past, encoded in the mythologies we've repeated for thousands of years, waiting for us to develop the scientific key to finally decode them. Perhaps the ultimate message from the first intergalactic travelers isn't waiting for us in the void, but has been whispering to us all along in the stories we tell about our own beginnings. And so our journey through the looking glass comes to a close, but what an astonishing trek it has been. From the ancient architects who might have seeded life itself to the ghostly quantum beings who simply step around the vast distances of space, we have wandered through a landscape of ideas where the line between scientific speculation and the grandest science fiction beautifully blurs. Each theory, from the cosmic gardeners tending their celestial plots to the desperate refugees fleeing galactic cataclysms, paints a unique and compelling portrait of what might be possible in a cosmos that has been evolving for nearly 14 billion years. The sheer diversity of thought on display is a testament not just to human creativity, but to the universe's own boundless potential for wonder. It reminds us that the truth of our cosmos, whatever it may be, is almost certainly stranger, more magnificent, and more mysterious than any fiction we could ever dream up in our limited time here. This isn't the end of the conversation, it is truly just the beginning. The greatest takeaway from all this is that the universe is not a static backdrop but a dynamic, possibly teeming arena of existence, and we are only now learning how to ask the right questions. Every one of these 30 theories, no matter how outlandish it may seem today, serves a vital purpose. It pushes the boundaries of what we consider possible. They are the intellectual playground where tomorrow's breakthroughs are born, challenging our assumptions and forcing us to look at the night sky not as a collection of distant points of light, but as a canvas of infinite possibilities. The real magic lies in the fact that we are here, right now, capable of pondering these profound mysteries, of weaving these intricate tales of what might be, and of one day perhaps discovering that one of them is not a theory at all, but a reality waiting just beyond our current understanding. Now we turn the discussion over to you. The cosmos is a story told by countless voices, and yours is a vital part of it. We are endlessly curious to know which of these theories captured your imagination. Did the haunting beauty of the sentient nebula speaking in slow gravitational waves resonate with you? Or were you drawn to the terrifying and awe-inspiring power of the warp drive pioneers, whose arrivals might reshape entire star systems? Perhaps the hopeful message of the cosmic gardeners, those gentle giants who see the universe as a place to nurture life, struck a chord. Dive into the comments below and share your favorite. Which idea made you stop and stare at the ceiling, your mind buzzing with the immensity of it all? Let's build a community of wonder right here, sharing our own speculations and marveling together at the grandeur of it all. If this journey through the cosmos's greatest maybes has sparked that feeling of awe in you, that childlike need to keep asking what if, then you are exactly where you belong. We are dedicated to exploring the furthest reaches of science, history, and mystery, and there is so much more to discover. To make sure you never miss an adventure, hit that subscribe button and ring the notification bell. We have so many more cosmic mysteries to unravel together, from the secrets of black holes to the puzzles of our own ancient past. So as you go about your day, carry a little piece of this wonder with you. The next time you find yourself outside on a clear night, take a moment, look up, let your eyes adjust to the depth of the void, and remember that you are not just looking at points of light. You are looking at potential homes, ancient highways, and perhaps even the watching eyes of those who came before. You are a part of this grand, unfolding story. Never stop looking up, never stop wondering, and never, ever let go of that relentless, beautiful curiosity that drives us to reach for the stars and ask what